Hi, friends. Happy Wind Down Wednesday. I'm so glad you're here with us this evening. Find someplace cozy to sit and we will get started. In class, we learned about a tradition that is coming up. On February 2nd, it will be Groundhog Day. It is a tradition that takes place in the United States and in Canada on February 2nd of every year. This tradition started from a group of German people who came together, and they believed that if a groundhog came out of its burrow on this day and they saw its shadow, then it would retreat or go back into its den where it lives, and winter would go on for 6 more weeks. And if it didn't see its shadow, then spring would arrive early. Now, this tradition still takes place on February 2nd each year, but studies have found that even if the groundhog sees its shadow, it doesn't necessarily mean that we will have a longer period of time before spring-like weather comes. So it's called a superstition. These people who were German used to believe this. But now we have data, right, information that scientists have looked carefully at that shows that a groundhog doesn't actually decide what our weather patterns will be like. Now, speaking of weather, in class, we have started to learn about weather. Today at recess, we monitored the wind by looking at a little white flag and seeing if the flag moved because there was some wind, if it moved a lot because there was a lot of wind, or didn't move at all because there was no wind. Today, we gave the wind a rating of 1 because it made the flag move a little bit. So when I was thinking about what story we would read this evening, I thought we would read about weather. Warning. Wild Weather Ahead by Theo Baker. Today in class, you each wrote about whether you like hot, warm, or cold weather better. Tell someone at home, what weather do you like best? Warning. Wild weather ahead. The dedication is to James Lovelock, creator of Gaia Hypothesis. And as always, my girls, Sarah, Anaris, and Electra. Lift off. This is an actual photograph. Do you think this book is fiction, made up, or non-fiction, not fake? Real photographs, headings, labels, facts. Non-fiction. Liftoff. Do you ever wonder where snow comes from? Put your thumb up if you've ever wondered that. Or why thunder crashes, or what it's like inside a tornado. Look, a team of scientists wants to learn more about the world's weather too. They're almost ready to launch a weather balloon. The balloon holds instruments, which are tools that can send back information about different elements of weather. It will fly into the air and allow the scientists to study the weather from up close. Let's see where the wind takes it. Let's go. Wind! We monitored the wind today. And then on our graph, we showed the data that we collected. Wind. The weather balloon climbs swiftly into the sky. As it rises, it begins to drift across the landscape with a warm wind from the west. Wind is moving air. The wind can move gently, such as a cool afternoon breeze, or it can blow with the violence of a hurricane. But no matter how it moves, wind is the driving force behind all of the world's weather. Wind happens whenever warm air and cool air mix together. Warm air and cool air are as opposite as night and day. Warm air is light and energetic. Cool air is heavy and sluggish. Sluggish. What word do you hear in the word sluggish? What do you know about slugs? They move slowly. So that means that cool air isn't moving very quickly, sluggish. And when the two meet, warm air and cool air, they push and pull and spin one another in strange and complex ways. Our planet's spin also causes wind. At the equator, the middle of the planet, Earth spins around and around at over 1,000 miles per hour. Though we don't feel the movement, this tremendous speed whips up the winds and sends them streaming around the world. Weather wonder. Earth is surrounded by the atmosphere, which is a protective envelope of gas. The world's weather happens in the troposphere, which is the lowest layer of Earth's atmosphere. Clouds. Have you ever seen a cloud that looks like something to you? Maybe it looks like a giraffe or a roller coaster. Maybe it looks like a car. I encourage you to look up at the clouds. What do they look like to you? Let's read about them. The weather balloon climbs high into the cool, thin air. The weather balloon isn't the only thing rising with the wind. The wind is also carrying dust, pollen, bacteria, and even baby spiders. Most importantly, the wind is carrying microscopic, very tiny, which means you can only see them with a microscope, which is a tool that you can use to see things that are very, very tiny that you can't see with just your eye. So most importantly, the wind is carrying microscopic droplets of water called water vapor. When there's enough water vapor in the air, the temperature is just right. Something amazing happens. What is it that you think happens when there is enough water vapor in the air and the temperature is just right? You can say, my prediction is, what do you think might happen? All around the weather balloon, water droplets begin attaching themselves to all those pieces of dust and bacteria. Then suddenly, as if by magic, clouds appear. So when there's enough water vapor in the air and the temperature is just right, clouds form. There are three main types of clouds. We're going to be reading about those different types of clouds, and we'll also be learning how to identify them. I can't wait to learn about them with you in class. Snow! Raise your hand if you love that weather. Some of you wrote that cold weather is your favorite. And then you drew a picture to match your sentence. Tell someone at home what it was that you drew in your picture, whether you like cold weather best, warm weather best, or hot weather best. The weather balloon is sucked into a big cloud bulging over the mountains. Columns of wind race up and down and side to side, and the weather balloon is pulled up higher and higher by the wind. The temperature drops below freezing. And then, for reasons scientists don't fully understand yet, a tiny droplet of water freezes into a six-sided ice crystal. Remember how we learned about how all snowflakes have 6 branches? In the blink of an eye, this single crystal draws other droplets to it, which freeze together. When this growing ice crystal is heavy enough, it falls through the cloud, triggering other cloud droplets to freeze together. The cloud is now full of snow. Many snowflakes get pulled up high into the sky, where they become a different type of cloud. The rest fall through the quiet air as snowflakes. Weather wonder. Snowflakes are made of air and ice, but mostly air. The amount of moisture in the air helps determine the shape of each snowflake. When there is moisture in the air, more intricate, detailed snowflake patterns form, while drier air produces snowflakes with simpler shapes. Rain! Touch your nose if you like when it rains. The weather balloon drifts to the other side of the mountain where it's warmer. Now the cloud is made up of both water droplets and snowflakes. The snowflakes are at the top of the cloud, almost 15,000 feet high. They continue falling through the cloud, but whenever they meet warmer air, they melt into raindrops. The raindrops grow bigger and bigger by sticking to other cloud droplets as they fall. Raindrops don't actually look like teardrops. They look like regular balls at first, but as they get heavier, they flatten out into a pancake shape. Once the raindrops leave the clouds, they fall to the earth at 7 to 18 miles per hour. Weather wonder. All the rain that falls to the ground eventually turns to water vapor and gets lifted back to the sky. And if you took all the water vapor in the sky and spread it evenly around the world, it would make a puddle about an inch deep. Thunderstorm. Touch your shoulder if you've ever heard a thunderstorm before. The rain cloud breaks apart. A hot wind has begun to blow. The land below is also hot, and the air is moist, which means a little wet. The sky has a strange yellow and gray color to it, and everything feels electric. The weather balloon is surrounded by an eerie blue glow. There's a big cloud that is stretching toward the top of the sky. It is a thick, dark, towering monster, and the weather balloon is heading right for it. The wind picks up, and with a violent gust of hot air, the balloon is sucked up into the center of the thundercloud. The sky goes black. The winds scream. Huge raindrops soak the balloon in seconds as it is tossed and turned and shot up at the cloud with frightening speed. Ice freezes around the balloon in an instant. The very top of the cloud is over 35,000 feet high, and above the cloud, violent winds swoosh downward, flattening the cloud top. The cloud flickers with electric blue and white light. Ooh. What is that called when you see light in the sky? Lightning. Suddenly, a massive lightning stroke explodes and thunder cracks. So first you see the light flash, then you hear the thunder. Thunder and lightning. Lightning has filled people with fear and wonder since the beginning of time. But even today, there is still much we do not know about this strange light in the sky. For reasons that aren't completely understood yet, thunderclouds become electrically charged, and so does the ground beneath the storm. When the thundercloud is ready to burst with electricity, a weak and invisible lightning stroke zigzags out of the storm down to the ground. Once it touches the ground, a powerful flash of energy races back up into the cloud. This return stroke is the one that we see. So it touches the ground and then it zaps back up, and that's the light that we see. It's not simply one stroke. And when they talk about the stroke, they're talking about that zigzag that we see. It's not simply one stroke either. A single flash is actually many different flashes. Lightning bolts heat the air around them to as much as 50,000 degrees Fahrenheit, 5 times as hot as the surface of the sun. Science knows somewhat more about thunder than lightning. A lightning bolt's amazing heat causes the air around the stroke to rapidly expand, right? Move apart and contract, come together. The air is moving faster than the speed of sound. And when two masses of air, groups of air, meet, they pound each other like a drumstick smashing a drum. Sometimes the drumming is low and rumbling, and sometimes it sounds like an explosion. Weather wonder. Sometimes lightning strokes melt the ground and form a hollow tube called fulgurite. They are so beautiful that many wear fulgurites as jewelry. Hail. Do you know what hail is? What's your schema? Conditions within the thundercloud have become more extreme. The weather balloon is flung up, shot down, and spun around wildly in heavy turbulence. The lightning flashes now seem almost green, and so does the entire cloud. The balloon is battered with what sounds like small rocks. The rain has turned to hail. Hailstones are not delicate like snowflakes. Instead, they are ragged and tough. They only come from the roughest thunderclouds. They form when falling rain is flung back to the freezing top of the cloud by powerful updrafts of wind. At the top, the rain freezes into an ice ball. Then the storm bounces the ice ball around the thundercloud like a pinball. Have you ever seen or played with a pinball machine? The ball bounces all over. Everywhere it goes, it picks up new ice layers, and it grows bigger and heavier until the storm can no longer support its weight. So what ends up happening? It falls. Most hailstones are pea-sized, very tiny, and fall to the ground at about 20 miles per hour. But hail can be much bigger. And the bigger the hail, the faster it falls. Hailstones the size of oranges can plummet to the ground at over 100 miles per hour. That's faster than a car goes. And they do horrendous damage. What do you think they could damage? Weather wonder. Sometimes giant chunks of ice fall in clear skies. These clear sky ice events are a complete mystery. Occasionally, they can drop ice chunks weighing over 100 pounds. You can chat with someone at home about something near you right now that is about 100 pounds. Tornado. The storm is not finished yet. It has become a supercell, a rotating storm system with strong updrafts. A hissing, whooshing roar rises from beneath the weather balloon, along with a strange smell. Down below, a spinning vortex opens in the cloud layer. A funnel cloud drops down, its walls swirling with lightning. The weather balloon is directly over a tornado. Science does not understand why tornadoes form, nor can science predict. Make an educated guess. Where they'll strike, how long they'll last, or how big and destructive they will be. Most tornadoes are about 75 feet across and have winds of about 100 miles per hour. But some monster storms can spawn a tornado over a mile wide with winds of over 300 miles per hour. Tornadoes can lift cars, pull the bark off trees, and destroy whole towns. Many scientists suspect that a tornado's destructive power doesn't come from its fierce winds, but from its low pressure. There is so little air within a tornado that it is like a vacuum cleaner, sucking everything up. Point to the tornado. There it is. Rainbows! Touch your nose if you've ever seen a rainbow. The tornado has broken up and has the supercell storm, leaving behind only a light drizzle. Sunbeams peek through the clouds, and a rainbow arcs across the sky. The lower the sun is in the sky, the higher the rainbow seems from the ground. Seeing a rainbow from the air is truly a thing of beauty. If the sun is just about to set, and you are high enough, the rainbow isn't an arc at all, but a complete circle. You can't touch a rainbow, nor can you find the end of it. The closer you try to get to one, the farther it moves away. A rainbow isn't actually there. A rainbow is, rather, a fantastic trick of light. We see rainbows when sunlight passes through rain at an angle. Each little raindrop changes the light's direction and scatters it. Although sunlight seems white, It's really a mixture of all the colors in a rainbow: red, orange, yellow, green, blue, indigo, and violet. A rainbow is unmixed sunlight. What's your favorite color? Our weather balloon has been through a lot. It floats gently down to the waiting scientists on the ground. But the scientists aren't done learning about the weather yet. They look up and see a weather plane flying overhead above the rainbow. Hurricane. This weather plane is loaded with instruments or tools. Now it is flying toward the ocean, but the ocean has a strange flat look. Long, rolling waves pound the shore only 4 to 5 times a minute instead of the usual 7 to 8 times. On the horizon, a looming mountain of black clouds covers half the sky. A hurricane is coming. This expert pilot is going to fly the weather plane right into it. A hurricane is a ferocious storm that unleashes heavy thunderstorms, searing winds, and devastating floods. The hurricane's power is fueled by the eye of the storm. The eye is usually 10 to 20 miles wide. The eye of a storm is the very center of it. Within it, the air is heavy and hot, much hotter than the surrounding storm. The air pressure is also very low, and this sucks up the seawater to the eye, which is the center of the storm. The spiraling winds inside the eye whip up this water and send immense rolling swells in every direction. And if the eye of the storm reaches the shore, a wall of water floods the coast, the land. Once a hurricane hits land, it will lose most of its strength within a day or two. Without warm water to feed it, to make it stronger, the hurricane loses steam and quickly fades back into the air. Weather wonder. Scientists grade hurricanes on a scale of 1 to 5. Kind of like how we graded the wind today on a scale of 1 to 3. A rating of 5 is the most powerful. Any hurricane above a Category 3 is incredibly destructive. Category 5 storms have sustained winds of over 154 miles per hour. Jet streams and ocean weather. Have you ever been on a plane? The weather plane flies through the hurricane several times, gathering data. We know what that word means. Data is information. We have been learning in math class how to show data on graphs. So far, we've learned about how to show data and read data, understand data that we look at on a picture graph. Then the plane starts climbing, heading up and up until it reaches the polar jet stream. This is a long, thin tube of wind that travels around the world with the winds between 100 and 200 miles per hour. These winds will give the weather plane a boost of speed as its instruments, its tools, collect information about the oceans below. Most of Earth's surface is water. This is a good thing because water is a remarkable substance. Unlike land or air, water heats and cools very slowly. The ocean's steady and mild temperature keeps the planet's winds from getting too hot or too cold. And since the wind goes everywhere, the planet's overall temperature is kept stable and mild. Without the ocean, Earth would broil in the sunlight and freeze at night. Cold places. The polar jet stream guides the weather plane over the frozen island of Greenland. Greenland is above the Arctic Circle and within a few hundred miles of the North Pole. Almost the entire island is covered with a sheet of ice, nearly 2 miles thick. So if you like cold weather, you would like visiting Greenland, which is above the Arctic Circle. Ice and snow cover roughly 10% of the planet's surface and play a crucial or important role in the planet's climate, especially the ice caps at the south and north poles. Ice and snow act like heat mirrors. They bounce most of the sun's heat back into space. Winds kicking off the ice cool the planet. Weather wonder. Only 3% of the planet's water is fresh, drinkable water, but most of the fresh water is locked up in glaciers and ice sheets. Deserts. If you like very hot weather, visiting a desert might be something you like. While the weather plane gathers data or information about the North Pole, astronauts aboard the International Space Station are watching a dust storm sweep across the Sahara Desert, the world's largest desert. One of the station's instruments, or tools, is collecting data about the dust so scientists can better understand how dust and other particles in the air affect the climate or the temperature. A desert is a place with so little rain or snow that few animals and plants can live there. Most of the world's deserts line the middle of the planet along the equator. But deserts can be cold too. In fact, Antarctica, the island continent home to the South Pole, is a desert. Though it is covered with ice, it is too frigid there, or cold there, for water vapor to escape from the ice and form rain or snow clouds. About a third of Earth's land is covered in desert, and the deserts are spreading. Weather wonder. The hottest land temperature ever recorded was just under 135 degrees Fahrenheit in Furnace Creek, California. The coldest was recorded by NASA in eastern Antarctica, where it got down to negative 135.8 degrees Fahrenheit. Global warming. The International Space Station orbits, or goes around, Earth once every 90 minutes. During these 90 minutes, the astronauts pass over deserts, glaciers, oceans, snow, clouds, water, all the weather the world has to offer. From space, it is easy for the astronauts to see that every weather event flows into the next one. Everything is connected. All of the world's weather is part of one global pattern. We are currently living through a new type of weather pattern, global warming. Human industry, things like cars, factories, power plants, they create a lot of waste like carbon dioxide and methane gas and pumps these greenhouse gases into the atmosphere. Once these gases get to the atmosphere, they act like a thick blanket, trapping heat and warming the planet. And no one knows exactly how global warming will affect the future's weather, but it could change the world as we know it. Ice caps could melt and cause the oceans to flood coastal cities. The oceans could become too hot and acidic to support complex life, and the spreading deserts could swallow up all our farmlands. The good news is that people have the power to stop and then reverse global warming. It will be difficult, but not impossible. The choice is yours. Global perspective. Earth is home to all sorts of wild and wonderful weather. Some of it is pleasant and calm, while some of it is violent and frightening. One thing to remember, though, is that all of it is connected. I loved reading this nonfiction book with you. If you enjoyed it, here are some other nonfiction titles that you may enjoy. I'm looking forward to continuing to learn about weather with you. I hope you have a great night, and I will see you tomorrow. Bye.